Okay, so now let's see. We've got to next describe 2D vectors a few different ways. So describe 2D vectors. And here's the whole reason vectors are hard. We're going to describe them mathematically, is that you jump between two coordinate systems. You may not have had it called this before, but that is the reason. In two coordinate systems. So we're working in 2D here, and we have two coordinate systems to think about. Okay? And often you'll do one part of a problem in one, and you'll have to switch and do the other part of the problem in the other, and you'll ask for the answer back in the first one, and you got to go back and forth. So I like to give them friendly names. So the first one is called polar bear coordinates. This will help. This will make it seem not so bad. Okay? So let's describe the vector 5 meters per second at 25 degrees. Say a problem gives you that. The velocity is 5 meters per second at 25 degrees. So there is an origin to the polar bear coordinate system, and you can draw this velocity vector at the origin. And we'll talk more about where to draw vectors. It's kind of confusing. It seems like you can draw them anywhere, and it depends. You can. But for now, we'll just say here is 5 meters per second, and here is the origin. And it's a mass moving, so it's not just the origin. We'll say that's the mass moving like that. And I always draw a little polar bear, my polar bear coordinate system like that. I practiced that all summer. We're drawing those for you. So this is the vector. We said, oh, if it's a velocity vector, it must have a v like that. Okay. And then what you do in a polar coordinate system is you draw a horizontal axis through the origin, or through the location of the object, which we're making the origin here, and you define the angle theta there. Okay. So let's look at some properties of this. So let's see. There's basically, it takes two numbers to describe that vector. It takes the size, the magnitude, and the direction. So this is how we define them in this coordinate system, is you put in magnitude bars or absolute value bars on the vector. Right? The vector itself, with a vector head on it, indicates both pieces of information, the magnitude and the angle. So now we're going to show you mathematically how you take that apart. You need the magnitude, and this is the magnitude. It's also just the length. It's also just the quantity, right? That's all it is. Not the direction, everything but the direction. Magnitude, length, quantity. And the main thing is, it's always positive. The magnitude cannot be negative. Right? Something can't have a negative length, right? It's always a positive length, okay? So you might see it like this, or you might see somebody put the bars like this and say, well, there's the magnitude and there's the direction. Or you could leave the bars off. The key is to know that the magnitude is just the length. Okay? And then theta is the angle counterclockwise from the right horizontal axis. And those are all important to keep up with if you're going to do this mathematically. Or you can do it by intuition. Both are allowed. All right. Somebody's pointing out that it's cold in here. I have heard that before. Let's see. So this is important. So we can talk about angles, and in problems there'll be angles all over the place. But if you want to follow strict mathematical convention, and sometimes you do and sometimes you don't, and I'll show you when you do and when you don't, this angle is 0 and positive is that way. If you want to be very strict and formal about where the origin of theta is, that's where it is. Take wherever your coordinate system is, draw a line to the right, that's 0, and positive goes counterclockwise, not clockwise. Okay? Okay, so that's polar bear right there. That's it.